Hi everybody, and welcome to our first webinar, 5G use cases for the energy vertical. Let me introduce myself. I'm Daniele Porcu, and I'm the project coordinator of Smart5Grid Project. Okay, the agenda of today, it's a brief introduction from myself, and then we will see one by one the four use cases we are dealing with in our project. The project, it's started last year in January. It will last 3 years. We are now in the half of the duration. It covers 7 EU states and it's composed by 24 member participants. The budget's not that big, it's 8 million euro. And in the map, you can see the location of the demo too. Let me have this opportunity to send a big thanks to all the partners participating. As you can see, almost half of the consortium, it's composed by small, medium enterprises. So let's start about the strategic view. Let's call it like this. The topic, it's energy. We will talk about energy vertical, and in the book in high school long time ago, energy was described, energy industry was described as a waterfall system, starting from the generation that was concentrating in a located big power plant, then a transmission grid, and a series of transforming substation to go through distribution network and the final users. In this system, it was pretty much predictable how the flow was going, because it was from the production till to the customer, and the energy was flowing only in one direction. What changed? The scenario with the high penetration of renewable energy went through a series of complications. The first one, it's stability of the grid, safety for field operation, because the energy can flow in a different direction. So if nobody knows if a part is alive or not, it's very dangerous. So that's why there has been, in the last 15 years at least, a new generation of smart grids that are keep on being updated. And in the last year, we saw also the presence of new actors in the energy market. All these points requires more reliable and stable communication framework, need for digitalization, and we also inserted in our vision new solution from third parties, because each and every actor of the industry can't anymore go by himself, but rather open into new solution available in the market, because the rapidity and the speed of innovation, it's very high. So this is a schema of the grid, how it's evolved now. So we have the high voltage grid, that it has also an interconnection through the countries. TSO network, it's considered as a pan-European grid. We inserted a series of generation in different voltage levels, and as you can see, we have a new generator distributed around the medium voltage and low voltage grid, while the customer are inserted in the low voltage grid. There are new actors, as I said before. They are called aggregator, but not only. We have flexibility providers that they are starting to become realities. We are just closing a parallel project on energy grid that is dealing with this kind of problems. So as you can see, the situation it's more complicated than it was before. Why 5G? Why 5G for system operator? To reach the field devices, until now, there was two options: optical fiber or 4G LTE. So if we compare 5G technology to with these two other technologies, we see that compared to the fiber, we have for sure lower implementation cost and a faster implementation, because you just need to bring your device without making digging conductors under the ground, and it gets high flexibility. For example, if we need to change the point where automation of the grid is, we just need to move the devices as a worst case to the next substation, and we are automatically activating. While for the fiber, it's very problematic. On the other hand, in 4G LTE, we have lower latency, higher stability, and also the opportunity to have virtually dedicated bandwidth. So, but this is only for from the transmission point of view. What we are investigating in this project, it's going in the direction of edge computing to foster the system resiliency. In particular, what we are experimenting in our project, it's called NetApp. It's an extension of what we usually consider as a MVF, network virtualization functionality, that is giving an abstraction of 5G complexity. So in this way, we can allow developers that they are used to develop in other paradigms to enter in contact with this new paradigm and build their own NetApp. A NetApp is a chaining of different virtual network functions. And for example, if we have a company, one of our consortium partners, for example, that it's very good in dealing with, I don't know, routing or slicing or firewall, they can build a standalone VNF, sorry, and someone else can find a ready-made function to become a part of their NetApp. So in this way, we can accelerate the development. So the key word of our call for proposal was really going in this direction, and we are fostering and it's our main goal to open for third-party participation. So in a while, and that's why we are here promoting the vision of the project, we will open for external developers to use our facility and develop their own NetApps. I understand that we are not the only project dealing with that. We have our NetApps that our NetApp structure and definition, it's more projected to be, or planned or thought to be compliant with the energy vertical. But as a concept, developing NetApp in spite of what will be the final agreement among stakeholders and projects, it's a way to enter in this new market, and we are very convinced about this approach. Last summary about the project. As you see, this is a little bit a roadmap, not the traditional way how to represent a Gantt. We started last year with the kickoff. We defined already our use cases and drafted and planned all the platform that are composing our system, our approach. We are now developing some of the components. The most interesting ones are the open service repository, through which all the external stakeholder or the partners can access to a kind of library of ready-made function or net apps, and the automatic validation and verification framework that allows developers to test and keep on checking in an iterative way if the NetApp it's working. And on our vision, this is facilitating accelerating the development. In red, I was highlighting the roadmap for third-party experimentation, and this is the first webinar of a series that it's going in this way. As I mentioned before, we will have 4 demonstrations all around Europe, and this is the object of our meeting today. So I'm leaving the floor to my colleague, just a little map for each and every use case. Italian demo, it's dealing with grid automation. So the position in the map of the smart grid, it's this one. So I leave the floor to Fabrizio Battista, my colleague, to present the first use case.
Thanks, Daniele. Okay. Second. Good morning. Just already said by Daniele, I'm Fabrizio Battista, and I'm involved in work package 5 inside the Smart5Grid framework. And in ENEL, I work like a telecommunication network engineer. Here, I'd like to explain the purpose of the use case 1 and his peculiarity. So let's start. Our demo will be realized in Sardinia, and its aim is to verify in a real field scenario how 5G network combined with NetApp could provide benefit in energy vertical. For this reason, we have selected some medium voltage line of Olbia primary substation, where will be available also the real-time self-healing, an important functionality historically in use in Enel grid solution. Our expectation is to obtain better performances of real-time self-healing by the 5G usage, with benefit directly felt by the DSO and his customers. In this demo, in addition to a distribution owner of grid, several different partners are involved, each with different expertise. So we have Win3, owner of the 5G network infrastructure. After we have also STAM will develop the NetApp, Atonet will provide the system where will be hosted the NetApp, and nearby computing will develop the NetApp controller from where will be possible to easily manage the NetApp. Well, it's a common view that the energy transition also passes by the digitalization of energy vertical. So in this context, we believe that solution based on 5G on public network, on 5G, yes, public 5G network, combined with the specific NetApp would provide benefit like an effort reduction for the DSO in the maintenance of communication infrastructure dedicated to the electric grid, and in the same time an improve of electric power grid stability. But before to explain how we believe this is possible, it's important to specify the meaning of some keyword that in this discussion I use. So when I use the word network, we are referring to the communication infrastructure. Instead, with grid, we are referring to the power distribution infrastructure. And in the end, with the real-time self-healing, we are referring to an advanced functionality in use in ENEL grid, able to perform the automatic research and isolation of a fault on grid when it occurs, and in a very short time, less than 100 milliseconds. It's clear that this functionality is an important leverage in the hands of a distribution in order to preserve the stability of grid. And to absolve this role, the real-time self-healing need a dedicated communication infrastructure able to constantly ensure relevant performances in terms of availability, stability, and speed. But unfortunately, this is not very easy to guarantee. And for this reason, a lot of resources are daily spent by a distribution to ensure the communication layer, to ensure that the communication layer perform in the better way. In our expectation, the NetApp can help to reduce this operative cost because provide to the technician daily involved in the network maintenance, in this case for a distribution, performances, data about the performances of the radio access network. So in this way, it is possible to quickly detect and fix a problem on communication network in more efficient way rather than now. At the same time, we also expect an increase of grid stability because the performances of communication network are strictly linked to the performances of real-time self-healing. So a reliable and very fast network enable the real-time self-healing to perform the automatically detection and isolation of an electric fault on grid, with an increase of quality of service provided to the final users connected to the grid. Well, what is our experience with technology used until now? As explained before, the maintenance of network dedicated to the electric grid application is not easy, even if it is fundamental in order to implement functionality like the real-time self-healing. On the one hand, because we must be compliant to several cybersecurity constraints to preserve our infrastructure by malicious subject, and on the other hand, because when we can't use fiber optic, the communication network is based on public mobile broadband network. So we must create a dedicated network from a general purpose network. And the NetApp, in our use case, can help the DSO to optimize the maintenance process. In fact, when a problem on this layer occurs, the DSO technicians can easily understand if it is originated by a radio coverage problem or not, and can focalize their attention where is needed. In our use case, the NetApp provide information about the radio access network performances. So as you can see from the picture, the part on the last part of the interior infrastructure on the left. And the NetApp collected this data from a privileged point from the inside the telco network. Is an important change than before. By the introduction of 5G network, in addition, we are expecting to overcome the problem related to the degradation of communication performances when our equipment are installed in area have a lot of subjects that using in the same time the local radio access resources. In fact, in all the network technology like 3G or LTE, the internet service provider can't guarantee a specific level of service to each different kind of traffic and in any condition. And in fact, actually, we suffer latency variation in area where a lot of final users competing with our equipment in the access to the mobile network, or also in rare cases when the public communication infrastructure is stressed by too many contemporary interaction. Some peculiarity of 5G network, like more resources available for each final users, in addition to the slicing function, could solve this problem. Well, here we want to show, obviously in a simplified view, what we mean with the electric grid represented in this scheme on the left, and what we are referring with the dedicated communication network infrastructure represented here on the right. In our use case, like in other section of ENEL's grid, there are a lot of sensors to realize the real-time feeding, and these sensors on field exchange information in according to the standard ESC 61850. And it is an international standard that defines how the electric devices on field must be communicated for realize innovative scenario typical of a smart grid solution. This standardized interaction on field are obviously realized by using a complex architecture, and also from this very high level communication scheme, we hope that you can catch its complexity and the benefit that the NetApp can provide with this data collection. Well, our expectation about the NetApp is to provide, in our use case, obviously, is to provide an example of a useful tool for all subjects that, in relation of their complexity and their needs, can implement a NetApp as a virtual probe to monitor their infrastructure and take benefit from his location inside the 5G network. This kind of application are only an example of new functionality and service that can be provided inside the 5G network. So let me say is a first step toward an innovative scenarios not fully predictable now. And the aim of NetApp that will be used in our demo will provide information about the quality of radio access network, as already explained before. For example, in terms of latency, error, and so on. And here we want to introduce a virtual probe, so a probe without dedicated hardware to generate and analyze the monitoring traffic directly from the inside the telco network. Is a very crucial point. So I stressed it. As discussed, we believe that with this kind of information can reduce the time needed to solve a problem on communication layer, because we can easily understand if it is originated by something in the radio access network or not. And for this scope, will be create a specific dashboard that will collect and summarize data coming from the NetApp, where will be highlighted some key performance indicator that will be customized by our operation. And in our mind, this dashboard will be an additional tool provided to the ENEL technicians involved in the monitoring process of infrastructure dedicated to the automation system. So that's all. I don't know if there are some questions.
Yeah, the Q&A session, it's open. Maybe we can collect your question, and then we will take some time to share them.
Okay.
So I see my colleague Ima. It's already sharing the screen. So Inmaculada Prieto from Distribución will present the use case number 2. Thank you.
Hello, good morning, everyone. My name is Inmaculada Prieto. I work for Distribución. Distribución is one of the Spanish DSO that belongs to ENEL Group. I'm going to explain to you use case 2. The Spanish demo consists of a remote inspection of delimited working areas, but made automatically at a distribution level. And we say distribution level because we are in a primary substation. The location for the demonstration is Barcelona. It will take place in the primary substation Ecogarraf. It's a 66 kilovolt substation. There are other partners in the demonstration, I2CAT that will deploy the 5G network, Nocia that will provide the sensors and the cameras, and Sidroco that will provide the artificial intelligence. Which is the objective, our business goal? Firstly, we want to improve worker safety in an electrical substation thanks to the usage of 5G communications. Why? Because we are in a high voltage substation. 66 kilowatts implies a very high risk. So we want to keep the safety of the workers, and it's necessary to keep the distance to any energized elements that must be at least 3 meters, not only from the workers, but also any tools that the workers may be using. Right now, the current procedure is to follow strict rules that tells the workers to keep the distance, to signaling the area with plastic fences or with poster or with danger signals, as you can see in the right side of the picture. But for us, it's not enough. In ENEL Group, we have the zero accident politics. Life has no price, so it's not only a question of cost reduction or avoiding failures in the power supply, but also because the life is the most important for us. So that's why our main objective is to border the safety area in a volumetric way, supporting these field operators using the real-time tracking system that is composed by sensors and cameras that will use the 5G network that provide an ultra-low latency communications and enhanced mobile broadband. And we will also include the artificial intelligence. And like that, we will have a real-time tracking system that will emit an alarm in any case that there is a trespass of the safety area, because of a worker or a tool that is worn by the worker. I want to show also this in the left side of the picture. You can see the selected area of the substation for the demonstration. We are in the Ecogarraf substation with the manual breakers, control switches. So this is the area that we use for the demonstration. Which are the advantages? As I said before, we are using a new technology. We are using a real-time tracking system that is composed by the sensors and the cameras. So we are reinforcing our current procedures, safety procedures. We are using a 5G new radio network that allows to transmit the information in a fast and reliable way. And above all, we also have the edge computing. The edge computing close to the radio access network, so the end-to-end delay is minimum. That's very important. And there we will deploy the NetApp, the application, the software application with artificial intelligence to process all the information from the cameras and from the sensor. So finally, we are improving the performance with the real-time monitoring, with the fast processing, and we are delimiting and monitoring the workers and the tools in real time. For us, it's of course an improvement, but we see or we think that other companies may have the same purposes. For example, other DSOs, other TSOs, any company that wants to delimit any security area and that want to avoid any breach in the security in a delimited area. So power plants, and also it's an opportunity to decrease the cost due to the maintenance, because whenever there is an accident, we have a failure in the substation, where we have a cut of the power supply. So this means not only a maintenance operation, but also a penalty from the government. So for us, it's a great opportunity. But above all, I want to highlight what I said before, that it's not only a question of cost, it's also a question of that the life of a person is really important for us. And of course, everything will help to improve our social image that nowadays it's not very good due to the cost of the energy and also because of the cut of the power supply and so on, the quality of service that we are giving to our customers. Now I want to explain to you the architecture and the peculiarities, the technical solution. And as I said before, we have the real-time tracking system on one hand that is composed by the ultra-wideband sensors and the cameras. Here we can see the cameras. They are 3D cameras that are joined to a processor that is called Jetson, and then they are connected to a switch. On the other hand, we have two different kinds of sensors. We have the fixed sensor, the anchors, and then we have the mobile sensor. The communication between them is with ultra-wideband, and all the information is sent to an industrial PC. The mobile sensors are worn by the workers, and then all the information from the cameras and from the sensors are sent through the CPEs, the customer premise equipment, through the 5G network to the different elements, and of course to the servers where the information is processed by the artificial intelligence. The 5G network is composed by the base station with an omnidirectional antenna and the server where the NetApp is deployed. We can manage all the platform of the 5G platform with the Neutron software. And then once that the alarm is emitted or triggered, is sent again by the NetApp, is sent again through the CPE to the alarm unit. And then the workers can visualize or view, not only visualize, but also listen to the sound of the alarm unit. We are going to use the frequency N77, and this will be requested to the ministry, the Spanish ministry, for this project. And I wanted to highlight also that this is a private network, and it's a very good demonstration because we can test everything without depending on an operator. The last topic is NetApp. The NetApp is the software with the artificial intelligence to process all the information from the sensors and from the cameras. It's the tracking function, and then the NetApp will trigger the alarm and notify the worker if there is any security breach. As I said before, it will be continuously collecting the information from the sensor, from the cameras in real time, in very fast speed due to the 5G communications. And we will also have a reporting of the KPIs. We will monitor how many trespass of the safety area were done, the speed of the workers, and so many parameters that we can configure and we can monitor. So we wanted to give you this idea of the demonstration without going very deeper, because the next steps will be to go deeper and to have other webinars. So I hope that you enjoyed the presentation. Thank you for listening to me. So if you have any questions, I think we can collect all of them, and at the end of the session, we can reply you. Thank you very much.
Thanks, Ima. And let me share again my screen. Well, so before continuing with the other two presentations, let me just summarize a little bit those two use cases. So in use case number one, we will make, or in the first demo, we will make in parallel two tests. On one hand, we will check if the real-time self-healing automation system is able to perform as well as optical fiber using 5G communication infrastructure. In the meanwhile, we will implement a NetApp also to understand better how this new developing paradigm is working, to monitor the 5G infrastructure from inside the telco premises. It was something impossible till nowadays to do. I can imagine the struggle of the people who is monitoring centrally all the communication with the field devices. When something is not working, they see the telco infrastructure as a black box. So having a probe virtually inserted, but also physically inserted inside the telco infrastructure, it's very supportive. In Spain, we will use a private network. It's the only pilot using a private network, while all the others are using a real infrastructure with all the problems that you can imagine that by the time we are implementing the project, the telco infrastructure is being implemented. So in Spain, we will give a support to the operators in a primary substation to monitor the safety. This will be done with advanced camera and sensors that will understand if the movement of people or some object will enter in the forbidden area. So next demo, it's covering the distributed generation, and somehow it's preparing the ground for aggregation, even if it's not available yet in Bulgaria. But with this NetApp, I think we will set the base for that. I leave the floor to my colleague Thanasis. If you can share your presentation, the floor is yours.
Thank you, Daniele. Just give me seconds. Can you see that in the presenting mode?
Yes, I also see my face in the rectangle.
Now it's better, I think.
Okay. Okay.
Yeah. Thank you very much. I am Athanasios Bachoumis. I am the technical leader for use case 3. I'm also an energy research associate in Ubitec Energy company that is based in Brazil, which aims at offering services regarding digitalization of the energy sector. The use case 3, it's about the millisecond level precise distributed generation monitoring, and is going to take place in Bulgaria. First of all, let's see the main drivers for this use case and the general context of the problem. First of all, we have on the one side the high res penetration in the different voltage levels of the electricity network. So we can find distributed renewable energy resources even on really in front of the meter in the medium voltage grids, or even behind the meter in the low voltage grid. This is the one aspect, and the second aspect is the decarbonization of the energy sector. So those two main pillars drive create a big challenge regarding the energy sector transformation. However, the high penetration of renewables provokes issues in real-time operation due to the high stochastic nature that those resources have. So thus rendering necessary the introduction of new flexibility services. As some of you may know, a lot of projects around the EU are dealing with the introduction of new flexibility services for the operators, regardless the voltage level. So we can introduce flexibility services even on transmission level or even on the low voltage level. So there is a really big amount of projects dealing with the introduction of those renewable energy services. The next pillar behind this use case is that in today's framework, most of the communication technologies used for the communication between the renewable energy resources and the power grid resources are still wire-bound. And of course, the last point is the massive digitalization of the energy sector, which actually primarily striving to facilitate the transformation of energy system. And this requires a stable, fast, agile, and reliable communication infrastructure and, of course, and telco solutions. Which is the value proposition of this use case? So what this case is about? This use case aims at dealing with real-time renewable energy sources production monitoring. We want to demonstrate very low latency in the monitoring of renewable energy production in order to be a first step to the the control of renewables with a really low latency. The second value proposition is that we have a predictive maintenance framework which will be enabled through the NetApp that is going to be developed in the context of this use case, and this will strive mainly for renewable energy assets. Of course, all this use case, all this framework that is demonstrated will enable the further participation of the aggregators in Bulgaria to offer flexibility services to the operators, and of course will visualize and provide analytics about the renewable energy sources production in real time. Those are the main pillars. And why 5G in this use case? Previous generations of wireless technology do not fill, of course, the criteria for low latency and high reliability in millisecond basis imposed by the use case specifications. The second point that strengthens the need for 5G is the participation of distributed energy resources in fast frequency response services requires orchestration, optimization of the assets, and assets activation in sub-second latency in order to meet the strict temporal requirements for service provision in order to keep bounded the abnormality in specific without having any problems to the network, any, let's say, domino effects. And anticipating and foreseeing the massive deployment of distributed energy resources that will penetrate the power system will create a need for new technology that could assist the transformation that the grid will experience, as well as the issues that will arise from that. The envision that more and more, of course, IoT-enabled energy devices that will be connected and controlled by newly introduced actors such as aggregators or flexibility service providers or directly from the system operators. This, of course, depends on the different business model that exists in each country. Will render necessary, of course, all this framework, the investigation of robust solutions that consider the scalability aspect. So this is another driver that actually sets the 5G need in this use case. And the last point is the widespread IoT ecosystem that includes million or even billion of devices that operate on a rate speed, have different bandwidth as well as quality of service requirements. To achieve that, technologies before 5G cannot provide the need coverage, latency, and security, cost optimization. So beside the different aspects of the value proposition that we shared with you before that are going to be demonstrated in this use case could be seen, let's say, as an enabler to further introduce more functionalities on top of those that will be demonstrated in the future, in order to grasp, let's say, and capture different needs that the developments in the business, let's say, models and in the technological advancements will set. So let's say which is the difference, which are the advantages vs the legacy solution that the demonstration that the use case 3 offers, all the activities of use case 3 offer. First of all, it offers real-time operation and maintenance. The second point is that we have a 5G network, so the transmission of the information for fast and reliable, but also will establish the last mile connection. We have the NetApps and edge computing, deployment next to 5G radio access network, minimum end-to-end delay. And of course, we have the performance improvement regarding power system flexibility. We reduce the problems introduced by the stochasticity of the renewables. And of course, we have resilience and security of power supply. Here you can see the impacted 5GPP KPIs on the network side on the left, and on the right you can see some business KPIs related directly to the energy vertical, and how this and how the use case 3 activities can further contribute to those business KPIs and how can improve the operation of the power system. You can see, for example, we will have a reduction in wind farm downtime, because I will show you later on that the demonstration activities will take place for a wind farm. So we will reduce the renewable energy, the RES asset downtime. Of course, we will have a reduction in the maintenance cost, reduction in the financial losses for the RES owner, which is directly linked to the previous two. We will have a decreased asset monitoring time due to the low latency monitoring of the power production, and potential for asset owner to generate additional revenues for providing ancillary services, or you can call them flexibility services, in the newly introduced framework. All of these KPIs will be calculated in the context of the use case, even directly or through simulations in the pre-piloting phase. Which are the target markets and opportunities? The proposed solution directly targets multiple stakeholders in the energy sector, like RES producers, balancing service providers, aggregators, even the newly introduced role of flexibility service providers, of course, system operators, original equipment manufacturers, and of course, third-party developers and SMEs that can build upon all and add new functionalities on top of those that will be demonstrated in the Smart5Grid project. So two different NetApps will be developed in order to realize the objectives of the use case 3. The first one will be the predictive maintenance NetApp, this NetApp will enable the predictive maintenance capabilities to the wind farm owner by gathering measurements from sensors of different vendors, capturing the performance of key components of the wind farm, and thus offering the wind farm owner information and analytics and insight regarding the asset performance and the power system operator information about the operational availability of the asset. So we will gather data from different vendors, will be a vendor agnostic, let's call it, NetApp, in order providing more insight to the wind farm owner. The second NetApp, which is about real-time production monitoring, will of course provide real-time data monitoring with a millisecond latency of the wind farm production. The data collection process follows similar approach as the previous, as I told you, NetApp. Different data points will be collected from the wind farm or from the SCADA system. It will also provide a bidirectional communication based for integrating the assets in future flexibility markets. And of course, this NetApp will foster the development of innovative observability models for power system operation, where the transmission system operators or generally the system operators can gain insight in lower voltage levels of the grid. Here you can see, I will not go in detail through the architecture, just a general concept. We have to mention that for the first time in Bulgaria, the 5G will be used for a demonstration for an application in the energy sector. So that's a pretty key point of this use case. So we will demonstrate the ultra reliable and low latency 5G network in the energy domain in a laboratory environment. We will transfer the real field measurements to the environment, to the laboratory environment where the 5G actually exists in Bulgaria. And through state-of-the-art protocols like MQTT will be used for data exchange between the Raspberry Pi HUT, which is a 5G enabled module, will be transfer the data to the hosting server of Vivacom. The Etra Energy is the owner of wind farm, and the Vivacom is the operator who is gonna host the cloud in order to demonstrate this setup. Additional validation activities will be performed using the hardware in the loop infrastructure for the pre-piloting phase of the use case in order to make some conclusions about how the demonstration activities in the context of this use case can actually provide advantages to the operators, to the power system operation, and to validate the applicability of 5G network in the context of distributed energy resources monitoring and control. That's all from my side. Thank you very much for attending. Please, if you have any questions, drop it in the Q&A session.
Thanks, Thanasis. Okay, I think you can see my presentation at the moment. Let's see together the last use case that it's dealing with cross-country wide area monitoring, and I leave the floor to Dimitrios Brodimas, the leader of the Greek demo. Dimitrios, the floor is yours.
Thank you, Daniele. Just let me share my screen. Okay, I believe that you can see the slides.
Yes, yeah.
Okay, thanks. Hello from me too. My name is Dimitrios Brodimas. I am a researcher at IPTO, Independent Power Transmission Operator of Greece. And my role in Smart5Grid Project is to be the use case for leader. Okay. Use case 4 is about the real-time wide area monitoring of power exchanges between two countries, Greece and Bulgaria. From the business perspective, the high stochasticity of renewable energy sources introduce issues regarding reliability and security of supply in wide area power systems. Hence, it is essential to develop a real-time wide area monitoring framework aiming to facilitate monitoring and control of the energy grid. The business goal of this use case is the real-time monitoring of the supervision area and the provision to the TSOs of information and strategies for the proper coordinated security analysis and operation of the system in real-time conditions. By doing so, the power system operates in a more robust way towards abnormal and dynamic contingencies that threaten the overall system balance. Okay. Regarding the actual objective of the use case, this objective refers to the creation of a wide area monitoring tool via the implementation of a virtual phasor data concentrator, a VPDC, that collects the measurements gathered by the phasor measurement units, the PMUs, installed in each side of the interconnected systems in Greece and Bulgaria. This tool will be using a 5G communication network and will exploit its underlying technologies such as virtualization and edge computing. On the map here, you can see the actual setup. The two PMUs will be mounted on the energy grids of Greece and Bulgaria in Thessaloniki and Blagoevgrad substations. And the edge cloud server will be located in Sofia. So let's figure out what PMUs and PDCs actually are and which is the added value of our solution in terms of the energy vertical. Okay, so the phasor measurement units, the PMUs, measure phasors of voltage and current, meaning amplitude and angle of voltage and current. Those measurements are time-stamped and they are sent to the virtual phasor concentrators via CE37118 protocol, and the VPDCs are implemented based on the CE37244 protocol. Before sending those measurements, those timestamp measurements, the PMUs compute the actual frequency of the grid and it adds this frequency to the actual data packets. In the legacy grids, if you like, the PMUs actually forward those data to the PDCs in a hierarchical way. First in a local PDC, then in a regional, and then to the central PDC located next to the SCADA system of the TSOs. Then the TSOs, if in terms of cooperation, they establish a common control room or a regional security center where they then forward those data in order to have a common view of the grid. As you can see here, all those layers introduce delay in terms of PDC and computational delay in terms of network delay between all those components. Something that inserts a lot of delay in the computation of several real-time phenomena that needs to be addressed as soon as possible. This is where Smart5Grid innovates, introducing a virtual PDC that directly connects two PMUs in two different countries and forwarding their data to the common control room. So the value of this approach lays on the direct connection, as I said before, between the VPDC and the PMUs via the cooperation of two communication networks belonging in two different countries and operators. The two networks are 5G enabled, fulfilling latency and bandwidth constraints that could not be reached by previous generation of wireless networks. Also, compared to the optical fiber solutions used in more legacy grids, energy grid, of course. 5G offers a more flexible and cost-efficient way of communication with similar values of the aforementioned metrics. And while speaking of metrics, here is a table depicting the impacted 5GPP KPIs. And as you can see, we have strict constraints in reliability and availability in order to be sure that the measurements from the PMUs will most definitely arrive to the VPDCs. And of course, for latency, in order to catch those varying phenomena and unpredictable phenomena, we definitely need to act as fast as possible. Okay, so here is a high-level view of the architecture that we're going to follow in this use case. As you can see, the two PMUs will spontaneously send their data to the VPDC, to the edge cloud server, who is going to host the NetApp. This NetApp of ours consists of three actual services: the VPDC and the advisory service and the monitoring service. And several tools such as orchestrators and NVIs are going to be used in order to orchestrate all this effort. Regarding the NetApps, as I already said, the VPDC is responsible for the aggregation and synchronization of the data provided by the PMUs. And it is going to be based on the SER 37244 protocol that describes the functionalities of the PDCs in general, not just the virtual PDCs. The monitoring service is responsible to present several status indicators and visualization features of the PMUs, such as the grid frequency, the FPS, the reporting speed of the measurements, or the phasor diagrams of voltage and current. Last but not least, an advisory service will be implemented that is going to propose remedial actions to the TSOs in real time, and of course provide them with several alarms in order to be sure for what's happening on the grid. Finally, regarding the target market and the opportunities aroused by our use case, of course, this solution, this framework that we are proposing, is strongly correlated with the energy market due to the use of the PMUs. So the customers of this solution are most probably TSOs, DSOs, or RSCs. Regarding the opportunity, it lays on the provision of a framework that enables fast fault detection at the edge, ensuring grid stability and ceaseless operation. So that's all for me. Thank you. And if there are any questions, please follow it on the Q&A session. Thank you.
Thank you. Thank you. Well, till now I don't see any question from the audience, but in the media I see few questions from the audience. Let me summarize a little bit these two use cases, and then we will go for the Q&A. So we saw two use cases. The first one in Bulgaria, and the next one in it's a cross-country Greece and Bulgaria. So the Bulgarian demo deals with distributed generation, and it aims to perform millisecond monitoring and predictive maintenance of distributed generation, opening for next market like aggregation or flexibility market. The millisecond capability of control capability allows for provide the flexibility in operational mode during, for example, a shortage to support the power also in a controlled islanded. I understand that it's very complicated to explain, but this kind of approaches have been already demonstrated in other areas of Europe. So this project is going in that direction of being ready for next generation of services. The last one, the Greek-Bulgarian demo, it's dealing with monitoring of the quality of the energy that is flowing between the countries. And thanks to the virtualization, it's allowing a more precise measurement, skipping a series of level, if I understood right, Dimitrios, a series of level of hierarchical interfaces to have a direct interconnection of substation that are directly connected. Okay, let's move ahead. I see that some answers were already given. If you want to comment, Imma.
Right. I see a question from Kiev. I don't know. Related to are these consumer grade CPs? Are they deployed in the field or inside an office? They are outdoor CPs. Keio Kantse, Marijuana, Sub-Sahara. Nice to talk to you. These are outdoor CPs, and these are industrial CPs, are not the consumer CPs. And then the other question was, if the full 5G network, the RAN and the core are operated by us? And the answer is yes, the confirmation. There isn't any participation of a mobile network operator. It's a private network that we built specifically for this project.
Yes, this if I can add, it's allowing us to test a series of service without entering in so much in technical detail, because this is not the table for that. But the telco infrastructure, it's made of last mile network, the radio access network, and the core network that is giving a series of services. And in this time is still not implemented in the infrastructure of the 3 telcos participating in our consortium. So this private network, besides of opening the opportunity to implement this solution in an isolated power plant, like the one in Spain, in Ecogarraf, that it's very far from the area covered by the telco, the local telcos. So it's enabling the use of this technology also in isolated power plants. It's allowing us to test all the core functionalities that will be implemented, like, for example, the slicing. That I understand that for testing only one use case, it's not the case of thinking about slicing, but we are also thinking about opening our use cases to our facilities to external developers. And then if we are running more NetApps implementing more devices in the same area, for example, in the same substation, we can guarantee a minimum bandwidth and a minimum slice of computational power to the NetApp to be executed. going back to the advantage of the NetApps, the most relevant is that it's providing flexibility. When the core network will be fully working, the topology foresee the presence of max server, that is the edge node, in each and every base radio station in a theoretical point of view. That means that if anything happen or the node is saturated, we can decide to move all our virtualized application in the next radio station, so that we will have a continuity of service that it's very crucial for grid operation. Let's see if there are other.
Yes, I think there is a question from George Stamoulis. I don't know if it is from the Emirates. I'm not completely sure. It says that he says that he would like to ask if cost-benefit analysis of the user of 5G in these cases has been carried out. In use case 2, it hasn't been carried out yet, but we would like to know the cost-benefit analysis, because the idea is to scale up the solution. As I mentioned before, we belong to a DSO. We are a DSO, so we have 1,000 substations with many workers. So if the solution goes well and we can implement this solution and scale it up, so we would like to know the cost benefit, of course. It's the first step before scaling up. So, and I don't know for the rest of the use cases.
Yeah, regarding use case 4, in order to conduct a CBA, we should actually monetize all the technical benefits that the 5G use will provide compared to the business as usual, let's call it, scenario. However, in Bulgaria, we don't have any flexibility market existing in order to remunerating the wind farm operators. So for us would be a bit difficult to conduct a CBA at this stage. It could be used only for any scalability in the future. Yeah.
Yeah, that's also an interesting point, that since the market is not ready, the regulatory framework is not ready for that. Maybe because there is not need at the moment for solving congestion problems, for example, as we saw in different parts of Europe. Great. I don't see more questions.
There is another question.
Yes, on a general level, you are talking about some level of openness and at the same time private network. As such, I guess the network utilized are not O-RAN networks. Any plans to go that direction towards using O-RAN 5G solution? Sorry for that. I'm not from telco industry. Fabrizio, if you have any clue about what is O-RAN 5G, at this point of time, we will use no standalone 5G core. That means that we will use the 4G core, while the radio segment is 5G. This is having at the same time a complexity. Is not easy, because we are dealing with working power plants, working substation with real people living along the power lines. So, for example, the Italian use case is implementing automation in existing medium voltage grid, while the Greek demo correct me if I'm wrong, it's working in parallel to the existing system, because the level of security constraint are very high. But we are comparing the responsiveness of the system with the legacy solution, and understanding if the solution is performing well. The next step is to scale up to all the TSO at European level, or at least introduce the solution as we already did with the Association of TSO as a member of our advisory board. We were introducing the project, and it's a really good approach, as they said. So concerning the 5G infrastructure, this is the state of art at the moment, and we will not be able to have the core network on time for test everything in the solution. But we will be able to test all NetApp's functionalities using the private network in Spain. Okay.
There was a question from Kio related to the equipment that we are using. I think the question was,
are you able to share which RAN equipment and 5G core you were using? Was Nokia, Ericsson, etc. I think it's the solution from.
Yes, we can share that the B-RAN equipment is Amarisoft. It's not Nokia nor Ericsson, and the rest of equipment is from Neutrum, the provider Neutrum, but the B-RAN is Amarisoft.
Okay, I hope the reply was exhaustive. So I don't see more questions. So let's close it here. Let me remember our expected result as a project. So I'm just summarizing the main topic. So we will develop and release. We are already in the beta test of Open NetApp repository. An automatic validation and verification framework. We saw some early stage prototype recently. We are on the way to start with our 5G real life demonstration that we are just explained today. And soon we will open our facilities for external experimenters that wants to understand more about NetApps and take advantage from our proposal to or our test beds to try in advance and be ready for the market in the future. Then the project is part of 5G private-public partnership that it's supervising the rollout of 5G technology. So we are actively cooperating with them, and we expect to have an impact on the change. It's very ambitious, I understand, but with your cooperation, it will be possible. So let me invite you to join our community, visiting our website and subscribe for the newsletter and following us on the channel. You can find our website and you can contact us for any further information. Okay. So thanks you all from my side and also from my colleague connected today to this to this webinar, and hope you see you soon in the next one dedicated to NetApps. Thank you all. Bye.
Bye.
Thank you. Have a nice day, everyone.
Thank you, bye.
Bye.